Everybody has the basic concept of the force. Everyone has the basic understanding of the force from everyday life. For example, whenever you exert force by kicking the ball, whenever you kick the ball, or either when you push the plate, pushing the plate. So in both of these examples, you are exerting the force. You are exerting force. So what kind of this force is? This force is comes from muscular activities of your body. This comes from muscular activity of the body. So what happened as a result whenever you apply the force by kicking the ball or by pushing the plate? Whenever you apply the force on the body, as a result the body will move. You can set the body into the motion, and there are some change in the velocity of an object, some change in the velocity of object. So whenever you apply the force, you set the body into the motion. As a result, there will be some change in the velocity of the object. But forces not always cause a motion. Force not always cause motion. For example, this one is let's suppose this is the table, and you are sitting here and you are reading the book, and still, but there is the force of gravity which are acting on the you. Still force of gravity is acting on the you whenever you are sitting on a chair or table and you are reading the book, but you remain stationary. So you and this force of gravity is still acting on your body, but you remain stationary at your place. So it means that forces not always cause the motion, but still forces are acting on your body. What causes the moon to orbit around the earth? So there was the scientist whose name Newton. The Newton was the first who answered to this question, and he said that what he said, he states that whenever the body move, he said that the forces always cause the change in the velocity of an object. Change in the velocity of an object. So it means that therefore whenever an object is moving with the uniform motion, let's suppose if object move with the uniform motion, to move with the uniform motion, the object need a force. So object need a force to maintain its motion. Which object is moving with the uniform motion? To order to maintain its uniform motion, object required the force. Now comes to the earth and moon system. As the moon is orbiting around the earth, as the moon moves nearly in a circular orbit around the earth, it means that the moon is changing its velocity. There is a change in the velocity of the moon, and this is a change in the velocity of the moon is due to the force which is exerted by the earth on the moon. So earth exerts the gravitational force on the moon, as a result of which there is a change in the velocity of the moon while orbiting around the earth. So the moon will accelerate. What happens when the several forces simultaneously acts on the body. Let's suppose we have an object, like an object is the car, and let's suppose there are the several forces which are acting at the same time. Let force is acting in this direction, force is acting here, force is acting from in this direction, force is acting from here, and force is also acting here in this direction. So in this case, here you can see that forces acting from upward, from downward, from left to right, and here you can see an important thing here to observe is that whenever the net force acting on an object is equal to 0, then this means that it refers to net. Here first I need to explain the net force. Here the net force means that the resultant force. Resultant force, or you can say that the sum of all forces. Sum of all forces. When net force which is acting on an object here is equal to 0, then the acceleration of the body is equal to 0, or when acceleration is equal to 0, then body either will remain at rest or it will move with a constant velocity. So here in the case of car, you can see that magnitude of the forces which acting in this direction and which acting in this direction from left and right are equal in magnitude and opposite in direction. So these forces cancel the impact of each other, and forces which are acting in the from upward directions, and these forces and forces which are acting from downward, these forces are also equal in magnitude but in opposite in direction. So these forces also cancel the impact of each other. So the net force, the resultant force in this case which is acting on the car is 0. So here the net force which is acting on this car is the 0. So if this car is moving with the constant velocity, it will continue to move with the constant velocity, or if it is at rest, it will remain at rest. So it means that whenever there is the no net force means that the sum of all forces or resultant force is equal to 0, then acceleration of the body is equal to 0, as we know that the forces always cause the acceleration. So whenever the net force is not equal to 0, when net force is not equal to 0, then it will cause the acceleration. It will cause acceleration. Acceleration means there will be the change in the velocity, of the car. As in this case, as all forces are equal and opposite in direction, so net force is the 0. So here the acceleration or the change in velocity is 0. But when the forces are not equal in magnitude, let's suppose if I change the direction of these forces, and if the forces are like this one, now the forces are acting in this direction. Now here in this case, the upward and downward forces will cancel the impact of each other, but the forces which are acting in the left side and right side, it accelerate the car in the forwardly. So its car will accelerate, it will move now, because now the net force which is acting on the car will not be equal to 0. Now we will consider the types of the forces. Now basically here there are two types of the forces. These are the contact forces and secondly, these are the field forces. Here the contact forces, which means that in which we directly contact contact the body by hitting, like by pushing or pulling the body, by pushing and pulling, and by directly hitting the body. And secondly, there are the field forces. Field forces are those forces which don't involve any direct contact between the object. Direct contact between object. So these are the field forces because they are exerted through empty space. They are exerted through empty space. So the first early scientists, including the Newtons, they were uneasy with the idea of the field forces, but later on there was the scientist whose name was the Michael Faraday. There was the well-known famous scientist whose name was the Faraday, and he gives an idea of the field, and it was between like the 1791 and 1807. So it was the time, during this time the Faraday gives an idea of the field. Before this, the scientist was not feeling easy with the idea of the field. So now we will discuss about the types of the forces. First, here we will consider the kind of contact forces. The contact forces here means that the forces in which we are directly in contact with an object. Like you can have like the pulling of the cart. When you pull the cart by exerting the force of your body into the cart, you are trying to overcome the force of friction between earth and cart. And secondly, like when you kick the ball, when you kick the ball into the in the air, and then again there is the direct contact between your body and ball. You directly hit the ball by exerting the force. So this is the kind of contact force. So other kind of the contact forces are, like you can see that pulling of the coiled spring, pulling of coiled spring. For example, this one is the spring which is attached to with the some sport, and whenever you pull the spring by exerting by applying the force on the spring, you can stretch the spring, or either you can compress the spring by exerting the force in the opposite direction. So these are a kind of contact forces in which you are directly in contact with an object and you are exerting the force on the object. As a result, there is the change in the velocity of an object. Another example of the contact forces are the gas molecules within the container. Here you can see that the molecule in the container, gas molecule, exert the force on the wall of the container. So this is also kind of the contact force because the gas molecules are directly hitting with the wall of the container. As a result, there will be the change in the kinetic energy of the gas molecules. So the other kind of the force is the field forces. The field forces, which I have already explained, that field forces do not involve the physical contact between the two objects. Rather, they are exerted through certain empty space or through some distance. Like we have an example of the magnetic forces. Here the attract each others through some distance, so there is some space, there is some distance between two magnets which are attracting each other. So when you bring the two opposite poles of the magnet near each other at some certain distance, they will attract each other. In the same way, when you bring the two same poles of the magnet near each other, they will repel each other. Again, repulsion is also the kind of force. Attraction and repulsion both are the kind of magnetic forces. So opposite pole of the magnet will repel each other when you bring the two magnets within the field, within the distance at which they feel within certain distance at which they can exert a force on each other. So here there is no direct contact between the magnets, rather they are attracting and repelling each other through certain distance, through certain empty space. So other kind of the field forces are the electric forces. In the electrical forces, let's consider an example of the electric charges. As we know that when we bring the two opposite charges near each other at certain distance, they will attract each other. They will try to come to near each other at certain distance. So there is a certain limit, there is a certain distance when you bring the two charges at that distance. So now they are within the field, so it means that they can attract each other. In the same way, like magnetic forces, the opposite same charges will repel each other. When you bring the two positive or either two negative charges near each other, so at certain specific distance, when you bring them at certain specific distance, they will repel each other. So there will be the force of repulsion. So both these kind of the forces, like magnetic forces or either these are the electrical forces, both are a kind of field forces, because there is no direct contact, there is no physical contact between the object, rather they exert a force at certain distance, through certain distance or through empty space. Other examples of the field forces include the gravitational field or gravitational forces. Gravitational forces. In example of the gravitational forces, like solar system. In solar systems, the whole solar system is bound to the sun by a force of gravity. There is the gravitational force within the solar system which bounds the solar system to the sun. So when there is also the force of gravity or the gravitational force between two objects, always every object exert a force on the other object, and this force is the gravitational force. So it is the gravitational force which bound to the earth's surface. So all these forces, gravitational force, here also you can see that the gravitational force is also a kind of field force, because it acts through some empty space or through some distance. So it requires it act through some distance through a field. So these are called as the field forces. This is an example of field force. Now the question is how we can measure the forces. So measuring of the forces. In order to measure the forces, we consider the forces as a vector quantity. Forces as a vector quantity, because here the direction of the force and its magnitude is very important. So the force is the vector quantity, so we need to use the rule of vector addition, rules of vector addition, in order to measure the forces. So in order to measure the forces, we need the rule of vector addition. Okay, now let's suppose consider that when the forces act vertically, when forces, as the direction is very important, when forces act vertically, let's suppose we have a spring balance, and this one is our spring balance. Let's suppose this one is the 3, and here we apply some force. This one is the force F1, and let's suppose here the scale will read the 1 centimeter. Scale read 1 centimeter. And let's suppose again we have a spring. We consider the spring balance, and we are applying another force, and this one is the spring balance, and again we are applying another force of greater than F1, and this is the force F2. Now the scale will read the 2 centimeter. Now when we both these forces are applied in the vertical direction simultaneously, when we hang the two objects, or when we apply the two forces simultaneously, so this is the spring balance. Now here this one is the F1 force, and this one is the force F2. Now the spring balance will read a 3 centimeter. So this means that here the net force, which is the combination of F1 plus F2. So in this case, when both forces are acting in the downward direction, in the same direction, and in the vertical direction, so we can add the forces. So one force reads the 1 centimeter, other reads the 2 centimeter. When their combined effect will be the 1 plus 2, it will be equal to the 3 centimeter. So the net force in the case of vertical force is their combined effect. Now let's suppose if when F1 is downward and F1 is horizontal, is the horizontal. Now both forces are acting in the different direction, and now again let's suppose we have a spring balance. It's like in this direction, and this one is the 0, 1, 2 and 3. This one is the scale of the spring balance. And okay, now let's suppose we have the two forces here. Now force F1, which is acting in the vertical direction or in the downward direction, and the force F2, which is in the horizontal direction. Now here we will consider their net impact of both forces. This one is the force F2, this one is the force F1. So this force is the horizontal direction, in the horizontal direction, and this force is in the vertical direction. As we have already discussed that this force was of the 1 centimeter, and this force weight was of the 2 centimeters. Now when both forces applied simultaneously, one in the vertical direction and other in the horizontal direction, now the scale will read, here the scale will read 2.24 centimeter instead of 3 centimeters. So now the rule of vector addition says that the magnitude of the resultant force in this case is equal to the F1 square plus F2 square, and this one is equal to 2.24 centimeters. So here we have used the rules of vector addition. According to rule of vector addition, as the forces are vector quantities, so we can apply the rules of vector addition in order to find out the resultant force. Thanks for watching. For more videos, please subscribe our channel.